Okay, let's continue. Multiplication of rational numbers. Let's begin. Can we multiply rational numbers? So let's see. Let mn be integers and not equal to 0. Let rs be integers s not equal to 0. So goal the goal is to define m by n times r by s. We want to define the product of these two rational numbers. Now m by n is the unique point box such that n times box is m. R by s is the unique point hexagon such that s times this point is r. We want to define so the goal we want to define the product of these 2 points. Box is defined as the unique point such that n times box is m. This point hexagon is defined as the unique point such that s times hexagon is r. And we want to define box times hexagon. Right. We have n times box is m. By definition, s times hexagon is r. Hence, n times box times s times hexagon is mr. We want to define box times hexagon, the product of these 2 points, such that we have distributivity, not distributivity, associativity. So we want to define the product such that we have associativity. N times box times s times this hexagon is ns times box times hexagon. We want to define such that this property holds. So this is above LHS. This we should be able to write it as ns times box times hexagon. In this ideal case, we have so this equation in this ideal case becomes ns times box times hexagon equals mr. That is box times hexagon, the product of these 2 points is mr by ns. In this ideal situation we have this, hence we define box times hexagon is defined as mr by ns. That is m by n times r by s is defined as mr by ns. right? So this is how we define product of two rational numbers. For example, 3 by 5 times 7 by 8 is 3 times 7 by 5 times 8. This is 21 by 40. Another example, 2 by 7 times 11 by 16 equals 2 times 11 by 7 times 16, and we can use the cancellation law to cancel 2. We get 11 by 56, right? So these are two examples. We can ask, does this multiplication agree with the usual multiplication of integers? So let mn be integers, then m by 1 times n by 1, which is mn by 1. This is mn by 1. Hence agrees with usual multiplication of integers. Right. So we can ask, what are the properties of multiplication? What are the properties of multiplication? Of rational numbers. So here's the observation. We have commutativity, associativity, and distributivity over addition. So commutativity, associativity, or let's not write it. We'll just write the observation directly. Multiplication of rational numbers satisfies commutativity. That is, order doesn't matter. It satisfies associativity. That is, grouping doesn't matter. And distributivity over addition. That is, a times b plus c is a times b plus a times c. So we have commutativity, associativity, and distributivity over addition. So the proof is as usual. First we prove commutativity. Let Rs be integers, s not equal to 0. Then, so if you first take m by n and then r by s, we get mr by ns. And if you first take r by s and then take m by n, we get rm by sn. And these two rational numbers, they are equal. Hence, m by n times r by s is r by s times m by n. Right, so order doesn't matter. Now we'll show grouping doesn't matter. We'll take three rational numbers, let mn be integers and not equal to 0. Let pq be integers, let rs be integers, s not equal to 0. Then if you first take m by n and then if you first multiply p by q with r by s and then multiply with m by n, we get m by n times pr by qs, we get mpr by nqs. And if we take m by n times p by q first and then multiply by r by s, we get mp by nq times r by s, which is mpr by nqs. So these are equal. Hence, grouping doesn't matter, the order in which we group. If we group p by q and r by s first, or if we group m by n and p by q first, we get the same product, right? So grouping doesn't matter. Lastly, we'll show distributivity, that this multiplication of rational numbers distributes over addition. Let mn be integers and not equal to 0. Let pq be integers, q not equal to 0. Let rs be integers, s not equal to 0. Then m by n times p by q plus r by s. This is m by n times, so this is sp plus qr by qs, right? So sp plus qr by qs, yes. We multiply both numerator and denominator of p by q by s and both numerator and denominator of r by s by q, and then add. So this is true, and then this is further m times sp plus qr by definition of product of rational numbers, m times sp plus qr by n times qs, nqs. Now m by n times, so the distributed product, so like m by n times p by q plus m by n times r by s, this is of the form mp by nq plus mr by ns. So this is smp by snq plus qmr by qns, and this is smp plus qmr by qns. And so this quantity here, smp plus qmr by qns, and this quantity here, smp plus qmr by qns, they are equal. So they are equal. Hence, if we have m by n times p by q plus r by s, we can distribute the multiplication over addition. You can write it as m by n times p by q plus m by n times r by s. Right. So we have looked at some basic properties of multiplication, and we defined multiplication and we looked at some basic properties of multiplication. So right, that's all for this part, and see you in the next part.